So we have discussed file storage management, first one control block, then block-based organization also we have done. Then I skipped the third one, file space allocation we didn't discuss. Then we discussed the fragmentation, then file allocation table and NTFS we have already discussed. So today we are going to discuss the third one, that is uh, file space allocation. That is a little bit big lesson. That means there are lots of past paper questions under this file allocation technique. Okay, so third one, file allocation. Now look at, no, don't write, I'll let you write later. So file space allocation. We are going to discuss how the file spaces are allocated in the hard disk or any storage media. Mainly this is about the hard disk. So files are allocated this space by operating system. Who is going to allocate the space? By the operating system. Where that means normally hard disk space is going to allocate by the operating system. So operating system deploy the following three main ways to allocate these spaces to files. So normally we are using three methods to allocate the files. First one, contiguous file allocation. Okay, contiguous file allocation means save the file as a group. Okay, so second one, link file allocation. Link mean like keeping pointers, whereas the next file is allocated like we are keeping some pointers in the link file allocation. Number three, index file allocation. Each and every file section consists of index number, like your class register, each student assign a class number. Likewise, if we are using some particular number, we call it as index file allocation. So now we are going to take one by one and discuss further, and we'll discuss lots of past paper questions under this chapter. Okay. So now write the heading file space allocation and copy this slide. Okay. Now think I want to execute this PowerPoint presentation. So PowerPoint presentation, I'll call it as a program. So this one, I think there are around 20 KB. Okay. So if I have 20 KB file, one file actually I have. So if this file want to execute in the computer, this is going, where are we going to execute? We move into the random access memory. Okay. If the space of the random access memory is not enough, then we have to take into the virtual memory, that is hard disk. Okay, I just write VM, virtual memory. So this program is going to break into same size blocks. That means it is going to divide. Just imagine I'm taking 5 KB here. Okay, normally the program is going to divide into blocks. Small blocks, but block sizes are equal. 3, 4, 5. Okay, so now altogether 20 KB are there. Now, when executing, this entire program is not going to execute at once. It is taking only part by part. Okay, because the RAM can't hold all the program at once. Therefore, RAM also consisting, RAM means physical memory. So it consisting frames. Okay. So frame also divided into same sizes, 5 KB sizes. So that is done by the operating system. සමාන කොටස් වලට කඩලා තියාගන්න මෙතන. මෙන්න මෙයාව ඒක ඇතුළට දාන්න පුළුවන් වෙන spaces equal කරගන්න. So the RAM also using same sizes we call as a frame. Virtual memory, that is in the hard disk. So that is a temporary memory. So virtual memory also going to break into same sizes. Okay, later we will discuss on that. Same block sizes, that is 5 KB. Okay, So the program is the one who is going to, that means operating system is the one who is going to decide the size of the block or frame or what page. Look at the word what we are using. When it's come to the virtual memory, we call as pages. When it's come to the random access memory, we call as frame. When it is in the program, we call blocks. Okay. So my file was 20 KB. That is partition. Break into 5 KB blocks. Altogether, how many? 5. Not 5 minutes. We should have only the 4. 4 into 5. 20, not this one. This is a free space. Just imagine. I need only all together, or else I'll take 25. If my file size is 25, then okay. 5, 5, 15, 20, 5, 25. So I'll make it as 25. If my program size is 25, then uh, the operating system is going to divide same block sizes, 5 KB, 5 KB blocks. So the block size is equal to the frame size in the random access memory. That is equal to the page size. Why? These blocks are the one which is going to go inside these places, moving one place to one place. For example, think you are in the level section maths class. Okay. If you are going to the ICT lab, there should be a particular size chair for you to sit. Okay. And if you are going to the physics lab, there should be a chair. It is suitable for you, not the primary Montessori chairs. හරි වාට ඉඳ ගන්න පුළුවන් වෙනම එකම size පුටුවක්ම තියෙන්න ඕනේ. IT room එකේ, physics lab එකේ, science lab හරි කොහෙට ගියා ඔයගොල්ලෝ ඉඳ ගන්න පුළුවන් size පුටුවක් තියෙන්න ඕනේ. primary nursery එකේ තියෙන පුංචි chair එකක් තිබ්බොත් ඉඳ ගන්න බෑ. අන්න ඒ වගේ program එක සමාන කොටස් වලට කඩනවා. අපි ඒකට blocks කියලා කියනවා. මෙන්න මේ block එක save වෙනකොට RAM එකේ ඒකට ගැලපෙන size එකම RAM එකෙත් හැදෙනවා frame එකක්. හරි RAM එකට අපි කියන physical memory. ඊට පස්සේ virtual memory එකට අපි කියන logical memory, virtual memory. ඒතකොට එයාගේ හැදෙනවා page එකක්. ඒතකොට page size equal to frame size equal to block size. ඊට මදි නම් RAM එකෙන් තියාගන්න බැහැ නම් virtual memory ඉතුරු භාගෙ දාගන්න. හරිද? ඒක clear නේ? දැන් මෙන්න මේ space block එකක් ගැන තමයි මේ කතාව කතා කරන්න පටන් ගන්න. Now we are going to discuss about this block, particular block. In our syllabus, they call it as a file. I don't like this word file. It's better to say space allocation. That's obviously okay. Or as block allocation. Okay. So now, first one is contiguous file allocation. Contiguous file allocation means now my program is PowerPoint presentation. Okay. So if the PowerPoint presentation want to save in the hard disk, okay, before starting that, just let me know where we are going to save the file in the hard disk. Hard disk, where the file save in? What are the things in the hard disk? Tracks are there. Don't think there's crooked one. Huh? Okay, there are tracks. And tell me, sectors are there. Okay, sectors also they are in the hard disk. And adjacent sectors we call as clusters. Very good, huh? Adjacent sectors we call as clusters. So clusters are the smallest unit where we are going to save the files. Why we call like that? Langa langa තියන sectors කීපයක් ඕනේ කියව file save කරන්න. තනි sector එකේ ඊට මදි වෙනවා. හරි? අපේ file එකේ size එක කීයද? 20 KB නම් මේක class එකක් හිතන්නකෝ 512 කියලා. ඊට මදිනේ. ඒතර ළඟ තියෙන මේ එක set එකක් 20 KB මේ 1 KB නම් අපේ file එකේ තියෙනවා 20 KB අපිට දාගන්න ඉන්න මදි. So therefore we have to use the adjacent sectors. ළඟ තියෙන sectors ටිකක් ඕන වෙනවා group එකක් විදිහට save කරද්දී අපි ඒකට කිව්ව මොකද්ද? class එකක් කියලා. හරිද? මම මේ මතක් කරන්නයි කියන්නේ. මේක theory එක ලියන්න දෙන්නේ නැහැ. ඒතර save වෙද්දී එක්ක sector එක save කරන්න ඕනේ. sector එකක් මදිනේ. මදි නිසා ළඟ තියෙන sectors කීපයක් එකතු කරලා අවශ්‍ය ප්‍රමාණයට හදාගෙන අපි ඒකට save කරනවා. So we call it as a cluster. හරිද? ඒතර මේ save වෙන එක දැන් මේ හිතන්නකෝ මේ blue color එකෙන් දැන් මේ මගේ PowerPoint presentation. Then I'll take another one, Word document. Hari. So if I'm going to save the file as a group, that means if I'm going to save the blocks as a group, we call as contiguous file allocation. අර කඩපු blocks ටික තැන් තැන් වල දාන්නේ නැතුව හිතන්න මෙතන එකයි. I blue color එකේ මගේ PowerPoint presentation එකේ pages 3ක් විතර එක තැනක තැන් තැන් වල save කරනවා කියලා. එහෙම කරන්නේ නැතුව ඔක්කොම ටික එක ළඟ save කරන්න ගන්නවා නම් අපි කියන එකට contiguous file allocation එකක් කියලා. Okay? So if you are saving 5 blocks as a group, we call it as a contiguous file allocation. If you are going to save here and there with the link තැන් තැන් වල හැබැයි point එක දාන්නවා කොහෙද ඒක තියෙන්නේ කියලා. ඉන්න තැන අඳුරනවා නම් තැන් තැන් වල save වෙද්දී if the pointing one is not link is knowing the where is saving, we call it as a link allocation. තැන් තැන් වල save කරනවා හැබැයි දාන්නවා කොහෙද ඊළඟ file එක තියෙන්නේ. ඊළඟ block එක තියෙන්නේ. file නෙමෙයි අතර block එක. ඊළඟ block එක කොහෙද තියෙන්නේ කියලා දන්නවා නම් අපි ඒකට link allocation කියලා කියනවා. තව එකක් මම දුන්නොත් number එකකින් index number එකක් දීලා මෙයා 1 නම් මෙයා 2 තැන් තැන් වල තියෙන්නේ ප්‍රශ්නයක් නැහැ. link එක තියෙන තැන දැනගෙන ඉන්නවා. තැන number කරලා දෙනවා නම් අපි ඒකට කියනවා index allocation. 1 2 හරි 3 කියලා තැන් ටික දානවා එකකින් call කරනවා. එහෙනම් link allocation. index එකක් තියාගන්න 1 එකයි 2 එකයි 3 එකයි කොහෙද තියෙන එක table එකක් තියෙනවා. ඒතකොට index allocation එකක් වෙනවා table එකක් use කරලා. ඔන්න ඔය ටික තමයි දැන් අපි deep කතා කරන්න හදන්නේ. Is this clear? So if you are going to save the file as a group, not the file, blocks as a group, we call it as contiguous file. Contiguous means langa langa. Okay. So if you are going to save here and there with the pointers, with the link, we call it as link allocation. If you are going to save with the index number, with here and there, we call as index allocation. Is this clear? Okay. So now only we are going to start the lesson number 1, contiguous file allocation. Don't write lesson. Contiguous allocation. Allocate space as collection of adjacent or as contiguous block. Adjacent anuyata langa langa thi. So if we allocate the space as collection of adjacent blocks. Adjacent block කියන්නේ හිතන්න මගේ මේ PowerPoint presentation 50 numbers ටික order එකට හරියට ළඟ ළඟ blocks ටික කඩපුවාම ඒවා ටික එක ළඟ group එක save වෙනවා නම් we call it as a contiguous file. Can you remember the fragmentation? External fragmentation. එකම group එක එකට දාන්න යනකොට ඉඩ මදි වෙනකොට අපි කියවනේ external fragmentation. So the contiguous file allocation will resolve the problem of the fragmentation, external fragmentation. Okay. So next, this slide no need. I just explained that one. Since I explained no need, write this one. You are writing only this one. And now look at this slide. Contiguous allocation means we allocate the block in such manner so that the hard disk, all blocks get the contiguous physical blocks. No need to write that note. Okay, just I took it for explaining. We can see the below figure indirectly. There are 3 files. Only this diagram you are going to draw now. Okay. So here there are 3 files. First one, ABC text file. That is notepad file. 0, 1, 2 are the file blocks. Then pink color one is the MP4 video file. And 9, 10, 11 is the Word document. And there is, I have already written there, 12, 13, 14 also there. Okay. So now see, 0, 1, 2 are contiguous. ළඟ ළඟනේ save වෙලා තියෙන්නේ. එක ළඟ තැන් තැන් වල නෙමෙයි. එතකොට 4 file ඒ දෙන්නත් ළඟ ළඟ තියෙන්නේ. Like a contiguous group. 9, 10, 11 also close by. If you get a file with 7 blocks. Can you save it as a contiguous? බෑනේ. ඇයි තැන් වල ස්පේස් එක තියෙන 7ක් තියෙනවා තැන් වල. 7 තිබ්බට එකට නැහැ. එහෙමනම් what is the problem? External fragmentation එනවා. ඇයි හැමෝම group එක විදිහට ඉඳගත්තාම වෙන පිටින් group එකක් වෙලා ඇතුළට එන්න ඉඳන් ඉඩ මදි වෙනවා. Can you understand the failure of this external fragmentation? Contiguous file allocation. Okay, so then another thing, if I want to increase the file size, තව වීඩියෝ එකකුත් දාලා PowerPoint presentation එකේ capacity වැඩි කරනවා නම් just imagine if I want to increase the capacity of the file, then can I get this more space? Sometimes the space is not enough නේ. අයියට තව ලොකු වෙන්න ඉඩ මදි වෙන්න. So that also another issue, the contiguous file allocation. Is this clear? So you are going to write only this one and not in this diagram, and then you are going to write the draw this diagram. Hold on, don't draw. I just finish explain, okay? Otherwise I have to break the video into two. Okay, now we'll discuss the advantages. So what are the advantages? The contiguous file allocation method gives the excellent read performance. That means easy to access, easy to read the file. Why? Files are blocks, sorry. Instead of files, better to say block. Blocks are saved as contiguous. ළඟ ළඟ තමයි block ටික තියෙන්නේ. හරි. හිතන්න ඔයගොල්ලෝ ඔක්කොම මියුසික් මොකක් හරි ෂෝ එකක් බලන්න යනවා. හරි. යාළුවෝ ටික ඔක්කොම එකට නම් ඉන්නේ. කතා කරන්න ලේසිනේ කට්ටියට එළියට. Since all the files are contiguous and saved as a group, then it is easy to access. Hard disk is going to pin the, that header is going to pin the location. Disk එක කැරකෙනකොට hard එක target කරලා touch කරන්න ඕනේ. ඒක තැන් වල හිටියාම seeking time එක වැඩි. ඔක්කොම එකම ඉන්නවනම් read and write කරන්න යන මේ වෙලාව අඩුයි. Why? Everyone, all the blocks are together. Therefore, it is easy to access. Then next one, easy to implement. හදන්න ලේසි ඔක්කොම එකට save කරන නිසා. Just think about the school assembly, main assembly. If all the math students are together, it's easy to call math student. Ne? If everyone mix up like a sport meet, ඔක්කොම ජම්බල් වෙලා කියන හොයාගන්න අමාරු. Access time එක වැඩි. So ඔක්කොම එකට තියෙන නිසා easy to implement. And the other one, contiguous allocation methods support both types of file access method, that are sequential access and direct access. What is sequential access? One after the other. A tape recorder එක අපි කිව්වේ first එක play කරලා ඊළඟ ගන්නවා කියලා. Well, that means normal magnetic tape also we are using sequential access. Direct access means CDs. So both method can be used in the contiguous allocation. Then last one එක තමයි ගොඩක්ම හොඳ. The contiguous allocation method is fast because this method number of seeks is less. The number of time which is getting for seeking හොයන්න යන කාලේ අඩුයි. ඇයි ඔක්කොම එකට ඉන්න හින්දා. Okay. Number of seeks time is lesser due to the contiguous allocation of the file block. තේරුණාද? ඔක්කොම files ටික එකට ඉන්න හින්දා තෝරගන්න යන කාලේ හොයන්න යන කාලේ අඩුයි. අන්තිම එක. Disadvantages of the contiguous allocation. But in the contiguous allocation method, sometimes this can be fragmented. This method is difficult to increase the size of the file due to the availability of the contiguous memory block. එයාගේ file size increase කරන්න බෑ. ඇයි? ඊට මදි වෙන්න පුළුවන්. තැන් වල ඊට සම්පූර්ණ ඉඩක් එකලම් ගන්න බෑනේ යාට. මැස් ළමයි ටික තව වැඩි කරනවා කියලා කිව්වොත් ස්පේස් එක මදි වෙන්න පුළුවන්. බිත්තිය කඩන් යන්න බෑනේ. ඒ වගේ ස්පේස් එක මදි වෙන්න. So next one, the external fragmentation can occur. පිටින් දාන්න හදනවා නම් file block group එකක් විදිහට එයාලට දාන්න ඉඩ මදි. හරි. Now this is clear for you. Then now we are going to write these slides. That mean just you are writing this one and this no need. Then this also only the diagram. This slide don't need. This also don't need. Okay. Just look at from this slide And this one, only the diagram. Here the advantages, then disadvantages. Okay, after we'll discuss the past web question 2019 one. Okay, so we'll start writing the notes.